minus y multiplied by 7 plus y like that. All right. So this is going to be equal to the limit when y is approaching minus 7. And then you can see that this and that will cancel out. So we are left here with 1 over 7 minus y. And then now, when we look at this new function that we have created, we could see that minus 7 is in the domain of our function. Therefore, we can do the direct substitution. So this is 1 over 7 minus 7. And this is equal to 1 over 7 plus 7, which is 14. Like that. So moving on to the second problem that we have here, we can look now at, say, 1.2. 1.2, we are required to evaluate the limit when x is approaching 0. The function that is given is x squared divided by 4 minus the square root of x squared plus 16. Then again, the first thing is to check whether 0 is in the domain of our function or not. Because if it is in the domain of this function, then we'll be able to do direct substitution and get the answer. But we realize that 0 is not in the domain of this function, because if x is equal to 0, then we will have 4 minus square root of 16, which is 4 minus 4, which is 0. And then in the numerator, we also have a 0. Therefore, we must do something. In this case, we are going to multiply by 1. We're going to multiply by 1. Let me put it like this. So this one is governed by what we have here. In other words, we look for the conjugate of our denominator, which now gives us 4 plus the square root of x squared plus 16. Divide this by 4 plus the square root of x squared plus 16. Like that. This is equal to the limit. This is equal to the limit of x squared multiplied by 4 plus the square root of x squared plus 16. Divide this by the product of this expression and that one, which will give us 16 minus x squared plus 16. And don't forget, x is approaching 0, like that. So from that, we realize that this is equal to the limit when x is approaching 0. Let us simplify the denominator. numerator, we have got x squared into 4 plus the square root of x squared plus 16, like that. And then looking at the denominator, this is 16 minus x squared minus 16, which is equal to the limit when x is approaching 0 of x squared into 4 plus the square root of x squared plus 16, close brackets, over 16 minus 16 is 0. So in the denominator, we're left with minus x squared, like that. Then when we move on, we see that this is going to be equal to the limit when x is approaching 0, x squared and x squared will cancel out. So we note that x squared and x squared gone, such that we end up with minus 4 plus the square root of x squared plus 16. Then again, we check whether 0 is in the domain of this function. And of course it is. So we end up with the limit x is approaching 0 of minus 4 plus the square root of 0 squared plus 16, like that, which is going to give us, this is not true. End up with that, because now we substituted, since 0 it's in the domain of our function. We no longer write the limit when we do the substitution. And this is going to give us now, as you can see, this is equal to our minus 4, our minus, then open bracket 4 plus, and then we have square root of 16, which is 4. This is equal to minus 8. There you are. So that was 1.2. That was 1.2. That was 1.2. So let us now look at 1.3. 1.3. We are given the limit x is approaching 2 of, pen bracket, x cube minus 5x squared plus 2x minus 4. Divide this by x squared minus 3x plus 3. Then we check whether 2 is in the domain of our function. Of course, to check whether 2 is in the domain of this function, we just take the 2, put it where there is x. We have 4. 4 minus 6. Sorry, this is 4 minus 6. It's minus 4 minus 6 is 2. 2 plus 3 is 5. So since this is a rational function, And we can see that 2 is in the domain of our function, and therefore we can do the direct substitution. And then this will be equal to 2 cube minus 5, 2 squared plus 2 minus 4. This is being divided by 2 squared minus 3 times 2 plus 3. This is equal to 2 to the power 3 is 8 minus 2 squared is a 4. 4 times 5 is a 20 plus a 4 minus a 4. Divide this by a 4 minus a 6 plus a 3. So we can see 4 minus 4 is 0. 8 minus 20 is minus 12. So we have minus 12 divided by, and then in the denominator we can see 4 plus 3 is 7. 7 minus 6 is 1. So the answer is minus 12, like that. So the thing is, before we do any substitution, we check whether the A is in the domain of our function. Because you recall, let me write here, recall that if A is in the domain of f of x, then the limit of f of x when x is approaching A is equal to f of A. We discussed this during our lecture. So that's very important, because in the next example, let us see what we have in the next problem. What do we have? We are given, let us do 1.4, 1.4. We are given the limit, we want to find or to evaluate the limit when h is approaching 5 of h minus 5 divided by the square root of h plus 4 minus 3, like that. Again, before we do anything, we ask ourselves, is 5 in the domain of our function? By the function, we are referring to this. This is our function. This is like our f of x, all right? So we are asking whether this 5 is in the domain of this function. In other words, when we substitute h, so this is our f of h, not f of x. So when we substitute 5 where there is h, do we get something which makes sense? You will realize that when we put 5 here, this will be 9. Square root of 9 is 3. 3 minus 3 is 0. We are forced to divide by 0, and also in the numerator we've got 0. So 5 is not in the domain of our function. 5 is not in the domain of our function. So because of that, then we rewrite this limit. H is approaching 5. Then we have h minus 5. Divide this by the square root of h plus 4 minus 3. Then we bring in the conjugate. We bring in the conjugate, which will be the square root of h plus 4 plus 3. Divide this by the square root of h plus 4 plus 3, which is just 1. So after doing that, we observe that now we will have the limit when h is approaching 5 of h minus 5, close bracket, multiply this by the square root of h plus 4 plus 3. Divide this by, now this is difference of two squares, so we are multiply, if you multiply, you have difference of two squares. So the middle term falls off. So we end up with h plus a 4 minus a 9, like that, which is equal to the limit h is approaching 5 of h minus 5, close the brackets, square root of h plus 4 plus 3, divide this by h minus 5. And we see that h minus 5, h minus 5 gone. So we end up with the limit. This is equal to the limit when h is approaching 5, limit of what? Limit of square root of h plus 4 plus 3, like that. Now, 5 is in the domain of this function. Therefore, we can write the square root of 5 plus 4 plus 3, which is square root of 9, plus 3, which is 3 plus 3, which is 6. There you are. So, yeah, that's how we deal with this kind of problems. So the rest, you can do number 6, number 7 on your own, just to check whether you are able to do what we've just done. Then the next one, let us look at 1.8. 1.8, we have the limit when x is approaching 1. X is approaching 1. The limit of x, the power of 4, minus 1. Divide this by x cubed minus 1. Close brackets, like that. Well, one way of doing this, maybe I can do it using two different methods. The first method will be Method 1. Well-known method. Is to factorize, right? Yeah, we know how to factorize this. So we have the limit when x is approaching 1, because 1 is not in the domain of this function. We can see that quickly. So let us factorize it the ordinary way. Numerator is x squared minus 1 into x squared plus 1. Denominator is x minus 1 into x squared plus x plus 1, like that. This is equal to the limit when x is approaching 1. Factorize again, we have x minus 1, x plus 1, x squared plus 1, like that. And from there, the denominator is still okay. Our denominator is okay. So we divide everything by x minus 1, x squared plus x plus 1. This is equal to the limit when x is approaching 1. And you can see that now this term and that expression will cancel out. So we are left with x plus 1 into x squared plus 1. Divide this by x squared plus x plus 1. Now, 1 is in the domain of our function. Therefore, we can do direct substitution. So this is equal to the limit x approach 1. Now we can do our substitution. So when we do our substitution, we no longer write the limit. We have 1 plus 1, close brackets, into 1 squared plus 1. Divide this by 1 squared plus 1 plus 1. This is equal to 2 times 2, which is 4, over 1 plus 1 plus 1, which is 3. So we end up with one whole number, 1 over 3, like that. All right. That was method number 1. Method number 2. Method 2. Let us remind ourselves of long division, because we have got 2 polynomials here, 1 over another polynomial. And so if we use long division, what do we have? We are dividing x to the power of 4 minus 1 by x cubed minus 1. So we divide x to the power of 4 by x cubed. We're left with x. X times x cubed is x to the power of 4. X times minus 1 is minus x. Divide this. Draw the line. X minus x to the power of 4 minus x to the power of 4 is 0. 0 minus x is just x. And then minus 1 there. Therefore, what we have is as follows. So we have the limit when x is approaching 1 of our quotient plus our remainder over our divisor. This is the same thing as the limit x is approaching 1 of x here plus x minus 1 over x minus 1 into x squared plus x plus 1, like that. This is equal to the limit x is approaching 1 of x plus 1 over x squared plus x plus 1. Then using limit laws, we have the limit of x when x is approaching 1 plus the limit of 1 over x squared plus x plus 1 when x is approaching 1. So for the first limit, we see that x, or 1 is in the domain of x, which is our function, and similarly here, 1 is in the domain of this function. So the first one will give us a 1. The second part will give us 1 over 1 plus 1 plus 1, which is 1 plus 1 over 3, which is one whole number, 1 over 3. Well, this method for this problem, it may look a little bit complicated, but there are some problems where it becomes very useful. There are some problems where it becomes very useful. Maybe you're also asking yourself a question as to why did we write like this? Why did we write that? Why did we write x plus x minus 1 over x cubed minus 1? No, it's just from the Euclidean algorithm for, shall I say, rational functions. Or if you remember, let us use, for instance, numbers, integers. So if, say, for instance, you have 7, you divide this by 2, what do you get? The quotient is 3 plus the remainder, which is 1 over 2, like that. So that's what we did. We have got 7 over 2. 7 over 2 is the quotient because 2 goes 3 times into 7, right? And the remainder is 1. So it's 3 plus 1 over 2 is the same thing as 7 over 2, like that. All right. So, yeah, as I indicated, this method can be handy sometimes. But for this problem, it may look a little bit challenging to most of you. Rather, you can just factorize. That's okay. All right. So going further,